Today we're talking about reflections and symmetry. A reflection is a transformation in which a figure is reflected or flipped over a line, and that line is called the line of reflection or the line of symmetry. Let's look at example number 1, identifying reflections. So if we look at A, we have a red triangle here and then a green triangle. So we want to know, is this a reflection? Has that figure been reflected? Well, if you look at the red triangle, it looks like it is in fact reflected or flipped. So I'd say yes. And it's flipped over, what would the line of reflection be, or line of symmetry? Well, it appears that it's the x-axis right here. It looks like it's a mirror image from here to here. Let's look at number B. I have two rectangles. Is this an example of a reflection? Well, if I look at this red rectangle, it does look like it's a mirror image over here. It's actually flipped over. So I'd say yes, it is a reflection. Flipped over what? Well, it appears to be here, the y-axis. Right here is that line of reflection. Our last example, C, I have two squares. Here's the red square and the green square. Is this a reflection? Has it been flipped over a line? Can I flip it over a line to get to that other square? No, I cannot. So that's not an example of a reflection. Let's look at some more notes about coordinates now and using coordinate notation. You can use coordinate notation to describe the images of figures after reflections on a coordinate grid. This grid shows us a reflection over the x-axis, that's right here, and this one shows a reflection over the y-axis, that's the vertical axis. So we look at our original line segment AB. The coordinates for A is -2, 3. The coordinates for B is 3, 1. And once I reflect that over the x-axis, right over here, down here, so I have the mirror image, the coordinates now become A prime. That's the notation to say that this is the reflection or the image. The coordinates become -2, -3. And then let's look at what the coordinates for B would be once I reflect it over the x-axis. The coordinates for B prime are 3, -1. Let's look at a reflection over the y-axis now. So we do have another line segment here, A, B. Here's our original. And A has the coordinates -3, 3. And B has the coordinates of -2, -3. Let's see what that looks like once we reflect that now over the y-axis. So I'm going to reflect it or flip it right over the y-axis right here. And that moves the line segment over here to have a mirror image, basically a mirror image of the original line segment. Let's look at what the coordinates would be. The coordinates of the reflected image is A prime now are 3, 3. And for B prime on the image, it would be 2, -3. What we want to keep in mind is that there are rules that we need to follow as far as reflecting figures on a coordinate grid and what happens with the coordinates of the original figure to the image. Let's look at the rules. First, if we look at reflecting over the x-axis on this example, we see the rules that the x-coordinates stay the same, -2 here and -2 here, but the y-coordinates change to the opposite. Let's look at that, 3 and -3 once we reflect it. Let's look at the reflection over the y-axis rules. I have that the x-coordinates change to the opposite. So when I reflect it over the y-axis, the x-coordinates, this was -3 here, and over here, it changes to the opposite, +3. Same thing with B, this point. Once I reflect it over the y-axis, the x-coordinate changes to the opposite, from -2 to +2. So we look at those rules, and they apply anytime we reflect a figure over the x or y-axis. So let's try reflecting a figure, reflecting a triangle. This is example 2. So you would draw a triangle ABC with these vertices that are listed. I have vertex A at 1, -1. That's right here. Vertex B at 3, 2, right here. And vertex C at 4, -3, right here. It says, then find the coordinates of the vertices of the image. And we're looking like we're performing a reflection here over the y-axis. That's our line of reflection or line of symmetry. So when we do that, we know that the original figure has these coordinates for its vertices, x, y, and they're listed right here. And they correspond right here to the figure that we just looked at. And now I want to look at the image. And it looks like the coordinates for the image, we know that we change the x-coordinate to the opposite when we reflect over the y-axis. So the image's coordinates are going to be -x, y. So let's rewrite these. Let's write the coordinates for the vertices of the images here, and then we'll be able to draw it in. So A is 1, -1. So then we would get the result would be A prime. That's going to be the image, and it's going to be the opposite of whatever x was. So instead of 1, it's going to be -1, and the y-coordinate stays the same. So it's -1 here, it'll be -1 here. Let's go ahead with vertex B and see what that would be. Well, it would look like we take the opposite of the x-coordinate. So instead of, let's put B prime here, instead of +3, it would be -3. And the 2 is the y-coordinate, and that stays the same when we reflect over the y-axis, so we'll keep it 2 here. Let's look at C, and now what the image would be. C prime. The coordinates for the image, we're going to change the x-coordinate to the opposite, so that would be -4, -3. The y-coordinate on that vertex stays the same. So now that I have these coordinates, I can draw in my image, and it's right here, A prime, B prime, and C prime. Those coordinates all match with what we just wrote in here. And what I want you to try to do now is, on your graph paper, draw a new triangle, ABC, with these vertices. We have A at -1, 3, B at 2, 4, and vertex C at 4, 1. I'd like you to reflect that triangle ABC over the x-axis this time and draw the image. Please refer to this so that you can see how you write the original coordinates for the vertices and how you write the image's coordinates for the vertices.